We are going to do something very strange. Theoretically, last year you were exposed to what's called the complex plane. Does anybody know what the complex plane is? Because it probably went zoop over your head, because even if you remembered it, it probably is like, what did we use this for? Complex plane? Complex plane is a plane in which this is the real part of my graph, and this is the imaginary. Not so long ago, we talked about the fact that you have no place to put an imaginary dot. Ah, in the complex plane, you do. You do. So, for example, if I ask you to graph 3 plus 2i, you would go 1, 2, 3, 1, 2, boom. That is the point 3 plus 2i on my graph. It's called a complex plane because it has both a real part and an imaginary part. Okay, so that's how I graph that spot. Here, we got it? Okay. Yes, sir. Yeah, there's a version of that. We're not going to do that, but there's certainly a lot of plane theory people will do x, y, and imaginary. And so the imaginary pops up or goes down through the real plane. We're not going to do that at all. Instead, we're going to use it. We're taking advantage of this to do some really weird math that's going to pop out of this once we start to play with this. Because last year they taught you this and then they dropped it, and you went, well, "Okay, that was the dumbest thing I've ever done. Why graph dots? I know how to do that, and what does it have to do with anything?" The answer to the question is trigonometry, right? Let's do some trigonometry now. How would this look in polar land? Can I locate that point in polar land? Sure, why not? I could go, how far is it out? How far would it be out? 3 squared plus 2 squared equals... No, the radius squared, right? Does that make sense? Radius squared? The r squared? And then I go r squared, so then I go square root of 13 equals r. Agreed? And then how do I find the angle? That would be, oops, I got that wrong. Hold on. Root 13, comma, and then how do I find this part? I would go theta. This is 3, that's 2. So I go tangent of theta equals 2/3, or theta equals the arctan of 2/3, which is, put in my calculator, hit equals, what do I get? Crowd goes quiet. You can do this. Have faith. Somebody can put this in their calculator. What? What'd you get? 33.7? That was it? Okay. So I'm going to go 33.7. I did it wrong again. That's really silly. 33.7 degrees, and this would be my polar version of the same thing. Agreed? We know how to do this, right? Kind of why we did this. Why hear a no? Okay. I don't think she said yes, but we'll move on. All right. Now, some things, some terminology. We are going to call this, when it's in a complex polar plane, yes, I just said that out loud. When it's in a complex polar plane, we're going to call this the modulus or absolute value. It is the radius of a complex polar plane. Yes, sir.
So, wait, for our project, do you recommend drawing it first and then doing the equations?
I recommend playing with equations first, seeing what you can do with them, then kind of thinking about it, drawing something, sketching something, and then making the equations and graphing the equations. Because you want to make sure you get the equations right. All right? That's what you got to nail that. But I would play with the equations first, see what kind of things I could make using polar equations. Once I got done with that, then I would probably try to figure out what I wanted it to look like when I was done. I will tell you the most successful ones are ones where you were saying, which is you try to draw it first and then you try to make the equations fit it. But that can be really time consuming. That really can. If you try to draw something that's really hard to do polar-wise, how are you going to pull that off? It takes a while. All right, so far so good. We're back to here. Okay, So we call this the absolute value or the modulus. Agreed? What do we call the angle?
Argument.
We're going to call it the argument or the amplitude. I hate that terminology because we use the amplitude someplace else, right? But it's called the argument or the amplitude. Now, ironically, why is it called an absolute value? Because you're dealing with complex numbers. You got an imaginary piece, don't you?
So how do you go from imaginary to...
Well, it depends on the question. We're going to talk about that a little more later. But right now, all we're going to do is graph it, and we're going to graph it polarly. And then we're going to play with imaginary numbers for a little while. And then we're going to come back, and we're going to put together it all together one big, really strange. We're going to learn how to do something you cannot do right now. Okay? If you want to, I could show you what we're going to do ultimately. Want me to show you briefly? Okay. You don't have to remember this. But you know, in your heart of hearts somewhere deep down, that this has how many solutions?
3.
3. What are they? 1. Totally agree with 1. What's the other 2? The other 2 are imaginary. How do you get those? This is how we're going to get that. Yes. So that's where we're going. But we got a couple steps in between. All right. So that's far. Okay. So you should be able to do these pretty easily. There's examples right there for you to do. So everybody try number 1 and see if you can do it. If you can do number 1, then we should be on a roll. So here's what we're going to do. We're going to go like this. We're going to go 3 in the I direction. 1, 2, 3 in the I direction. Agreed? So what would its absolute value be? How far it is from the center point? How far is it? Cassandra? 3? That's all it asks for. I'm going to do the angle anyways. What would the angle be?
Oh, I was thinking of it.
It'd be 90 degrees, wouldn't it?
That's it.
That's it.
Wow.
That's actually more than it asks for, but I'm going to ask for you to do the angle anyways. So please do the angle as well, even though it doesn't ask for that. All right, do 2, 3, 4, and 5, and then we will endeavor to pick this up later. Number 2.
So is I just 1?
I just 1. So we're going to go 1 squared plus 5 squared equals c squared. That becomes 1 plus 25 equals c squared. C equals the square root of 26.
Okay.
So the absolute value or the modulus would be root 26, comma. What's the angle? Going to have to do a little thinking on that one. I've got 1 over 5 tangent of theta equals 1 over 5. So theta must equal the arc tan of 0.2. I'm going to go for my calculator.
Wait, this right?
Yes, sir.
Oh, okay.
Arc tan of 0.2, and I got 11.3. Is that right? 11.3 degrees. Again, it's not asking for that on the worksheet, but let's go ahead and do it anyways because we need it later anyways. All right.